Hey folks. Okay, well, a while back we looked at a little handcrafted scanner. This time around we're going to look at a handcrafted parser. So this is going to follow the sort of top-down approach that we were discussing in our last couple of sessions. It's going to be pretty simple. It's for a really basic language and it's going to be a simple parser, but it gives you a good idea of the kind of structure that you can look at for something like this. So the contents of our little parsing repository here, pretty much the document itself, will have a .c file that's got the code for it, and our parser is, again, pretty rudimentary. It's just going to be one big main routine for the most part. We'll have a header file that's got the different token types and non-terminal types defined in it. And for the moment, I'm just going to put the token stream that we're going to parse in a tokens.h. So it's hard-coded. This parser at the moment just reads this one input stream. If you were going to use something like this, then presumably you would have a scanner that generated your tokens.h and you compiled it and ran your parser. So it's clunky, but it illustrates the parsing point that we want to go through. So maybe we'll just take a quick look at the contents there and I'll come back and talk about stuff. So again, contents of our repository, we've got makefile to build it. Parser is our executable. The parser.h. In here, we'll go through and have a definition for each of the different token types that we're going to support. And so I'm just using an enumerated type for that. And then I'm actually using the same enumerated type and we'll list the non-terminal types after that. So there's essentially just a unique identifier for each different kind of symbol that can appear in one of our derivations. And it's either a token that's less than or equal to our token equals, the last token here, or it's one of the non-terminals. So I've got a couple of extra enumerated values set up to indicate what's the highest value for a token and what's the highest value for a non-terminal. But pretty straightforward, and maybe another enumerated type just for the possible results from our parser, incomplete, fail, success, something along those lines. And then in our tokens.h, again, this has the token stream that we're going to be parsing. So it's got this sequence of tokens that we're going to go through and process from beginning to end, and just a counter of how many tokens there are in total. So that'll come back as we take a look at the code later. And again, our parser.c has the code for it, and it's basically, well, I've got one extra kind of debug helper here that takes your token type and will print out a string that matches it. So if it's the integer token, it prints out int. If it's a prog non-terminal, it prints out prog, something along those lines. But nothing very fancy there. And our main routine, we'll take a look at the algorithm shortly. We'll have a stack to keep track of the symbols that we still need to process. We'll have that input sequence that we're going to go through. And we'll keep track of where we are in our input and how many things are on the stack right now. And we'll have the current symbol that we're looking at processing. And again, we're going to start that off with our top level non-terminal. And we'll talk about the algorithm itself in just a bit. All right. So as far as the language is concerned, we've got about 8 different token types. So there's tokens for ints and reals to represent integer real number or integer numeric values or real numbers. We'll have var to represent variable identifiers. Oh, pardon me, int and real are our data types. Inum and rnum are for the actual literal values. Print for a print function just built in. EQ for the equality operator. And term for a statement terminator for semicolons. Oh, I forgot to put the semicolons at the end of my little example here. So each of these would have a semicolon at the end. Dope. Let's see. So as far as our grammar rules go, a program is just a list of statements. A list of statements can be either a statement followed by a list, or it can be empty. So essentially, if I've got a whole bunch of statements, it'll apply this rule multiple times, and then for the last one, it'll turn the list to nil. Statements can be either essentially an assignment statement where we say a variable is equal to and some further assignment, and it ends in a terminal, or it can be print some variable and ends in our semicolon or whatever it is. Int to declare a variable of a type, so int, the identifier, and a terminator. or real and the identifier and a terminator. And then the actual assignment portion of our expressions over here can either be a var is assigned, whatever the our continued assignment expression here, or a numeric value. So essentially this can create things like x equals y equals z equals w equals a equals b equals c, and then eventually somewhere far over on the right hand side we'll have either an integer literal or a real number literal. So that's pretty much all the program can do. So again, we're going to have, just as a little sample program, presumably our tokens would have regular expressions associated with them to describe what an actual identifier could look like, what string would equate to an assignment operator, what the terminator might be. So again, we might have the terminator might be a new line, or the terminator might be a semicolon, or a period, or whatever it happens to be. But again, our code's going to look something like int x, real y, int z. But all I'm going to show in my input stream are just the token types that would be recognized here. So again, we're just keeping this pretty simple just to show the parsing portion of it itself. All right, let's see where we can get to. So again, we'll have token types and non-terminals as we looked at in our parser.h. And we're just going to have one big array of these as our input stream. And we're going to keep a stack of the symbols that we need to process, so our terminals and non-terminals. And again, that's basically just going to be a glorified array. So our parsing sequence is just this repeated process where if we see a non-terminal, then look at the next character in the input sequence and pick a rule, push the right-hand side symbols onto a stack, pop the top one off and use as our new current value. Right? And that's our handling of non-terminals. So this is pretty much the algorithm we talked about in our last session. And if the current thing is a token instead, so if it's something that's actually supposed to appear in our source code, then it better match the front character in the or the front token in the sequence that we've got left to process. If it does, then we can move on to the next character in our input sequence, and we can discard this token and replace current with whatever's on the top of the stack. So we'll pop the top thing off the stack. So what we do if it's a non-terminal, what we do if it's a token, and if it's anything else, then we've run into a problem. So it's just going to go through this loop over and over and over again until either we hit an error or we hit the stack and input sequence are both empty. So just have a quick look at the code for this. You'll see our while loop is pretty much doing that. While we've still got stuff in our stack, or we've still got things to process in the input stream, we'll keep on going. We'll check, and again, I use that last token in our enumerated type to keep track of the what value distinguished tokens from non-terminals. So if the enumerated value is bigger than last token, then it's got to be a non-terminal. So that's all that our quick and dirty test is doing here. If it's a non-terminal, then we'll do a switch based on that. So we'll look at which non-terminal it is and decide how to process it. So if it's the prog non-terminal, we've only got one rule for that, right? If prog goes to list, so we push list onto the stack, right? So this is just pushing list onto the stack. And again, we're just printing out what we're doing as we go along. If it was a list could either go to nil or to our to a statement followed by a list. So if there's still stuff left to process, then it didn't go to a nil. So we'll push the list first, since that's got to be on the bottom of our stack, and then we'll push our statement last. If it was a statement, then it could be one of a variety of things. It could either be an assignment, a print var, an int var, a real var, or one of those assignment non-terminals where it was var equal var equal var equal type of thing. So we'll have to figure out, based on the next input character, the next input token, which one of these things to use. So if the thing up front is a var, then it's one of those assignment cases. If the thing up front is the int keyword, then it was an int var. If the thing in front was a real, it's a real var, etc., etc. So if it was a, and then the last case there should be the print. If it was a print, right? So based on whichever one of those it was, we push the right-hand side components. So if it was a var, then there should be var equals, and then one of our assignment non-terminals, and then whatever our terminating symbol is, semicolon or whatever. Right? So we push those things and proceed. Again, if the thing we saw next was the int keyword, then it should be int, and then a var, and then a terminator. Right? So we just push whatever the right pieces are based on the type of non-terminal we're working with and the next character that we're looking ahead at. And of course, if it's anything else, then they gave us some kind of an invalid token somehow. And again, if it was an assignment non-terminal that we popped off the stack or that we're looking at currently, then it should be var equals, and then either, we recurse through this var equal, var equal, var equal, or it's a literal value, either a literal integer or a literal real. And in either case, right, if it's a literal integer, then we want to push that onto the stack. If it's a literal real, we want to push that onto the stack. If it's one of these assignment things, then we want to say, okay, well, it's got to be a var, and then an equals, and then more of an assignment statement. Right? So we just keep going through this. And again, if it's anything else, then we hit something we didn't recognize. Once we've processed it, right, once we've pushed the right-hand side elements onto the stack, we pop the top thing off of the stack into current. Right? So we pop the top thing off. And of course, if we've hit the bottom of the stack, we'll want to remember that. We want to remember that the stack is actually empty. So that's all our processing for the non-terminals. Right? Just looking at all the different cases, and for each of them figuring out which rule we should apply, and therefore what we should be pushing on the stack. So the other possibility is that it's a token rather than a non-terminal. So in that case, we want to look at it and see if it matches whatever's in front in our input stream. And if it does, that's wonderful, we've matched something. So in that case, we can advance where we are in the input stream, and we can pop the top thing off the stack into current for our next pass through our loop. And again, we want to remember if the stack is now empty. And of course, if it didn't match, if it wasn't a terminal and it wasn't a matching token, then we've got a problem. Right? So we just keep on going through that until eventually either we run into a problem or we exhaust our stack and our input sequence at the same time. So we can either decide, yes, it worked, or no, it didn't, and report the results. So that is the idea. So if we run this beastie, again, it's just going through that sequence of statements in our tokens.h. So again, this corresponds to our kind of int x semicolon, real y semicolon, int z semicolon, x equals z semicolon, or pardon me, y equals, say 0.5 and a semicolon, print y semicolon, x equals z equals 10 semicolon. Right? So the token stream that we're parsing is one that would correspond to that sample program we were looking at earlier. And hopefully, if we actually cycle through this, again, it goes through and starts pushing terminals or non-terminals onto the stack. Right? So we recognize that in the beginning we needed to go from prog to a list, and then we needed to go from list to a statement followed by a list, and then we could start working on that statement. Right? So we look at the statement and figure out, oh, this must be an int var term, so it pushes those things on the stack, and it matches the int token, and it matches the var token and the term token that are in our input stream, so it's getting rid of those as we go. And then it pops what's on top of the stack off, which is going to be our list at that point. And so we've still got input to process. So it says, okay, a list must go to a statement followed by a list, and it starts trying to process the statement. Right? Okay, our statement, it's looking ahead at the next character or the next token, and the next token is real. So it says, oh, I better use this rule. Statement goes to real var term, and it's pushing these things on the stack and matching them as we go, right? It's looking at that front thing, saying, well, the real matches, so we'll pop the next thing off, and the var matches what's next in the input stream, the term matches, and it just slowly works its way through our input stream, either picking a rule and pushing the appropriate elements onto the stack, or popping the top thing off the stack and seeing if we've got a token that happens to match. So there is the process. Again, it pretty much implements the techniques that we were talking about in our last session. And it gives you an idea of how simple it is to do that in code. All right, I think that was everything I wanted to address here. Again, the only correction, I will go back and update the web page here, but these should have terminators on them, so there should be something like a semicolon or whatever we're using as a term. I guess I could cheat and claim that the new line was our terminator here, but I'll make that a little bit more explicit. All right, I will leave it there.